Hello, hello, check.
Okay. Hello. A very warm good morning to each and everyone present here. I, Suniti Kumari, research scholar, heartily welcome you all in the technical keynote of First International Conference on Advances in Water Resources, AWaRe 2025. In the continuation of Conference Day 2, we are going to start today's technical keynote. It is my great honor to introduce our keynote speaker, Professor Rajib Kumar Bhattacharjya. He is currently serving as professor in the Department of Civil Engineering at IIT Guwahati. Earlier, he worked at NIT Silchar and in Zohrat Engineering College, Assam. His comprehensive academic foundation encompasses a BE honors from Regional Engineering College, Silchar, ME in Watershed Management and Flood Control, Assam Engineering College, and PhD in Hydraulics and Water Resources, IIT Kanpur. His research expertise spans multiple critical areas, including computation, hydraulics, impact of climate change, surface water groundwater interaction, assessment and management of groundwater resources, flood modeling, assessment of flood hazards and vulnerability, optimization methods, including ANN. This diverse research portfolio reflects his comprehensive understanding of complex water resources challenges. His scholarly contribution include authorship of many peer-reviewed scientific publications in various international journals and conference proceedings. His international recognition is evidenced through prestigious fellowships and visiting positions, including Shastri Indo-Canadian Institute Fellowship for, uh, for academic visits to Dalhousie University, Halifax, Canada, Erasmus Mundus Fellowship for research visit to École Centrale de Nantes, France, and MFP Fellowship for attending programs at UNESCO IHE Institute of Water Education, Delft, Netherlands. His multiple visiting scholar and faculty position at Dalhousie University, Canada, spanning from 2002 to 2010, demonstrate sustained international collaboration and recognition. Dear delegates, please join me in extending a warm welcome to Professor Rajib Kumar Bhattacharjya. I would like to request Professor Bhattacharya to deliver his session.
Good morning, everyone. So I'll be presenting. So this is a real problem we have studied and it has been implemented. This is a very recent work, salinization of Ganga at Prayagraj. And this work was done for the Kumbh Mela 2025. So I would like to share my experience on this particular project. So I think all of you know Kumbh Mela. So this is a huge gathering. I think this was the highest gathering in the world, human gathering, religious gathering in the world. So this time it was in this January, and and you have almost 400 million people gathered for this particular event. And then when we are preparing for this particular event, so there are a lot of challenges. And one, so basically challenges was that the river was, so I have shown on the right hand side, so you can see that is the river during around January, February 2024. So if you look at that, you have actually the Ganga was the braided channel. Okay, so there are some multiple channels, so three prominent channel. And what was happening? So there is a stream, and Ganga is flowing like this, and there is a Jamuna here. And so what was happening? That so they need a single channel. Suppose for ritual bathing, so you need a single channel. Otherwise, you can say that which one is basically the primary channel. So one single channel was required, and because it was spanning over 1 kilometer, the depth of the flow was very less. Okay, so if depth of the flow is very less, then it is not suitable for your bath. So that was the basically problem at that time. So with this, so we are invited. IIT Guwahati was consulted during that time, and so they said that the primary objective is that we need a single channel from your there is a railway bridge that is called Sastri Bridge, from Sastri Bridge to Sangam Nose. So single channel is required. So that was the main objective, and another objective is that you need sufficient depth. So depth has to be maintained. It should not be your 10 feet or 15 feet. So it should not be something like that, but around up to 1.5 meter or 2 meter depth is required near the your Sangam nose. Okay, so that was the primary objective, and we came actually during February 2024. That was the first visit. So during that, we This is the basically condition of the Ganga. Ganga was a braided channel and fragmented state. Water level was very low, making unsuitable for ritual bathing. Then there is another issue because this is Mahakumbh. Okay, so around 400 million people will gathered, and over the year, suppose if you compare 2019, so this was the 2019. So this area, whatever I have shown, this is known as Sangam nose basically, and this is the Triveni Sangam at the nose basically, and that is the places and people are going. This is the so now, if you look at this is the 19 bank line. So compared to 19 bank line, that right hand side of the Ganga was eroded. Okay, and so one objective is that so we should reclaim that area which was eroded over the year. So from 2019. So that was so 2019 means that is the line basically whatever I have shown yellow line. So we have to reclaim the Ganga up to that one. So there are two main objectives. So with that, these are the objective. One is the transform the braided Ganga at Prayagraj into a single stable channel. Okay, so that was the objective, primary objective. And then second objective was to ensure adequate water depth for uninterrupted holy bath. And third was the to reclaim. So we have to go back to 2019. So they said that if we get the area what was available in 2019, so then it is sufficient for us. So we have to reclaim the 2019. That means this side, right hand side of the area has to be reclaimed. So these are the three main objectives of this particular study. Then what are the challenges we have basically? Okay, so one is that, so if you look at, this is at that time, 2024, January or February month. So main channel was on the right hand side. Okay, so right hand side of the river was eroded. So main channel was the right hand side, and depth was very high, basically more than 15 feet or something like that. So depth is so primary channel on the right hand side of the of Ganga. So that was the and second, now how to basically push it. So for pushing, I think those who are working in river training work, so we can put some spar or we can put some other hydraulic structure. So to push the river to that one. So this is one. Then second one is that basically, so I can dredge that one. Okay, so I can dredge a channel. But what will happen if you dredge a channel, if there is no gradient, then what will happen? That dredge channel will be silted after some time. So you can dredge it, but in one monsoon itself, so that will be silted. So therefore, yeah. So therefore, what will happen? What will happen? So even if you are you do the dredging, I think you have seen that dredging was not successful in many part. Okay, so we are also doing at Brahmaputra. In Ganga also some part dredging was done, but it was not successful because the gradient will not be there. Once gradient is not there, so what will happen? That in the next monsoon, the dredge channel will be silted up. So you have to take some precautions so that that you are not getting silting on the dredge channel, and dredge channel become bigger. That was so. This was the key challenges. Unfavorable natural flow path. Natural flow path was on the right hand side. Okay. Then resistance from the natural gradient. So resistance from the natural gradient. Yeah. So this is basically the problem. So now suppose natural flow is this side, and we would like to we want that channel should be on this particular, and this was actually at that time it was completely silted. Okay, so we need the channel here, and but natural flow on this side. So that was the basic challenges at that time. So then the third challenges was, you just see the Kumbh Mela will be, so we are invited in 2024 February, then Kumbh Mela will be next year, that means 25 January. So they need, and everything has to be done during that time, okay, between February and December. Now you just see, after so February, then monsoon will start in July or something. So we have only few months till monsoon, okay. And before monsoon, we have to study this thing, and before that, we have to get the bathymetric data. Then we have to complete the study. Then we have to give the suggestion, And the irrigation department in UP, irrigation department was responsible for implementing this project, and they have to implement that one. So there was a time constraint because it has to be done within a very short time. And second was because you just see now this is you are trading a river. So you don't know actually, suppose if I put a hydraulic structure, what will be the behavior? I'm predicting that, okay, there may be siltation in this area, there may be something, but it may not happen. So when there was a first meeting with the Mela authority, I said that, suppose if you have given me 2 years, I could have done very nicely. Okay, in the first year, I could have done some piloting, and if there is anything, I could correct in the next year. But we didn't have that option basically for correction, because whatever you will do basically or whatever you will propose, it has to be implemented and we have to get the result. There is no option for correction. Okay, so that was the time, limited time window, and there was a very limited time, because before monsoon, suppose I would like to reclaim this area, suppose then I have to do before monsoon. Okay, so we are in February, so we have hardly 3-4 months to monsoon, and before monsoon we have to complete the study, we have to implement the project so that we can get some siltation on the right hand side of the your Sangam nose. Okay, so that was the challenges we had. So now, what is the conventional strategy? Those who are working in river training work, okay, so in Assam, so we have Brahmaputra, so we played with Brahmaputra. So now you just see, suppose if you want to do the siltation, okay, so if you want to do or reclaim some area, what we use basically, so we use porcupine screen. Okay, so porcupine screen is basically a permeable spar. Okay, so what will happen if you are putting porcupine screen, the velocity will reduce, and because of reduction of velocity, there will be siltation. Okay, so that is the traditional way. So now porcupine can be a concrete one or it can be bamboo one. Okay, so this is the traditionally we are doing. But here the problem is that they were not ready to use porcupine. Okay, so one is that because if you are putting porcupine, then what will happen? This concrete bar or bamboo bar will be there, and during Kumbh Mela, that will create some problem. So they were not ready to use porcupine screen. So therefore, but they were ready to use, and it has to be implemented within a 1 month or within 15 days, something like that. So they were happy with geotube. Okay, so because geotube is easily available, if you tell some contractor, so they will bring that on and easily it can be implemented. So they were happy. So basically, finally, because for siltation you need permeable spar. Okay, geotube will deflect the flow, but there will be some siltation, but for siltation you should go for some permeable spar. But because of these limitations, what we did basically, so finally we didn't opt for your porcupine screen, so we have opt for geotube. Okay, so this is the alternate strategy, that we have used impermeable spar, not so we have used geotube cutter basically. So now this is yeah. So now basically the another is that for siltation of this area, reclaim area, so we have planned that we will go for geotube. Then the second is that we need to dredge a channel. Okay, because the channel has to be shifted to the left. Okay, so to the left basically, and basically, so this is the dredge channel. So we did control dredge your channel. Okay, so define a central single channel from Sastri Beach to Sangam Nose, and so that we are getting one. So now the idea was something like that. So initial. So now suppose so this is the dredge channel. This is the dredge channel. But natural gradient is this side. Natural gradient is this side. So now, if you are dredging this, but flow will not be in this channel, okay? Because necessarily flow will be on this side. So therefore, you have to redirect the flow in this channel. So we put some your spar there, okay? So this is a some small spar, 2 spar we have given at the upstream, and this spar is basically this spar is basically deflecting the flow towards the your dredge channel. Okay, so that spar was used. And then another concept was, now basically what is happening, we are putting geotube cutter. So they call it cutter. Actually, this is not up to the high flood level. This is hardly, so we have put in 2 layers. And so here basically we are putting geotube cutter. So idea is that, so once you are putting geotube cutter, then the cross section is reduced in this natural channel. Okay, the cross section here will reduce. So once cross section is reducing here, the flow will be through the dredge channel. So that was the concept of implementing this one. And with that, basically, so we have put some geotube cutter up to the Sangam nose. So that will induce siltation here, and cross section will reduce. And as a reduction of cross section, the flow will be on the dredge channel. And we have also put two spar there, and this spar was used to deflect the flow towards the your dredge channel. So this was done basically. So we have installed geotube cutter at this location. So now, so to identify the channel and other river training work, so we have done some studies. Okay, so we have collected the your LiDAR data of the entire stress basically. So we have the very high resolution DM data of this area, and for the river section we go for echo sounding. So we have a very high resolution DM of the river section. So we did the morphological analysis, and then we have identified the channel. So basically we tried to go for some previous channel because there was some gradient earlier, so we tried to put that one, and then we have designed the river training work. Okay, so based on that, and then we have the data. So data, high resolution data, as I said. So we have the high resolution data. We have the flow data of Ganga and Jamuna, historical flow data, and there is a control structure. Actually, all flow to Ganga was controlled by the barrage at Kanpur. So that data was also available. And then we have modeled this area. So model this area using HECRAS. We have used HECRAS, and idea was that, so we need to find out. So modeling was basically, so whatever the river training work we have proposed, so that was tested in the this mathematical modeling. Okay, so we have tested because suppose the spar you are using, so what should be the length of the spar, what should be the your that inclination or basically alignment of the spar. So that has to be decided, because if it is too long or if it is somewhere if you are misplacing, then what will happen, the other side of the bank will be eroded. Okay, or you may not get optimal result. So various alternative has been tested using this mathematical model, and based on that, so finally we have, so this was done basically because the river training was done pre-monsoon. So we have tested that what will be its impact during the monsoon and during the low flow, means high flow simulation and low flow simulation, during monsoon and during lean period. So that has been tested using that HECRAS model. So now we have divided the work in basically mainly three parts. Okay, one is pre-monsoon. Okay, so this is the pre-monsoon, and during monsoon there was not much work, and after monsoon, post-monsoon, we have planned. Okay, so pre-monsoon, that was very important because we need to reclaim that area. So therefore, first is we did the controlled dredging. Okay, so this dredging was done based on the simulation study or these things. So we have fixed an alignment, and on that alignment we did the dredging. So define a central single channel from Shastri Beach to Sangam nose. So that was basically done pre-monsoon. Then we put the geotube, your cutter basically. So we put, this was installed pre-monsoon. Okay, so pre-monsoon it was installed, and these two your spar also installed your pre-monsoon. So this was the pre-monsoon activity. So pre-monsoon flow that it was around the RL was flow that water level was around 78, 75 or 72, something like that. So at that time, so we have installed this thing. And basically, so after installation, okay, so we actually, what happened, because I told you that time was very short, because after our your study, they have implemented, and they should also go for some official procedure to allot the work to the contractor. So finally we could install here, but some of the this also installed, but we could not do everything. Okay, so then monsoon came, the flow level, that water level rises, so they stopped that one, but we could complete almost 80% or 90% of the proposed work during that time. So now you just see, so this is the drainage channel. Okay, this is the drainage channel, and this is the alignment of the drainage channel. So this is in Ganga and this is in Jamuna, and you can see. So this is the drainage channel that pre-monsoon we basically constructed. So this is the drainage channel. From this is your upstream side. This is the Sastribis, and downstream is the Sangam. So we are going towards the downstream basically. So this is the your drainage channel constructed or dredged before monsoon. Okay, so you just see this is the drainage channel, and right hand side you see right hand side, that the flow was on the right hand side basically, but our aim was that flow should be on the drainage channel. So then basically monsoon phase, as I said, so we didn't have much work because we can't do anything, only to monitor. But during monsoon, they have monitored. They have done the echo sounding, whether we are getting the siltation or not, basically as per desired this thing. So there was no intervention was carried out during monsoon, except we are monitoring the river bed. Okay, so entire period was spent monitoring natural response to the pre-monsoon measures, the high flow condition. So it was actually last year, the high flow was very long actually. So up to late October, monsoon was late October. So everything was submerged up to October. Okay, so we didn't say anything, except we got the monitoring by echo sounding. So then basically what happened, this is the video taken around November, I think 14 November or something, 10 November or 14. Okay, so there was a video conferencing. So I was at Guwahati. So we had a video conferencing, and this video was drone video was taken. And then when I saw this video, so you will see that the way we expected, exactly it was happening. You just see the right hand side here. You see the right hand side is everything is silted basically. So this is the area we tried to reclaim. There was some small channel, but most of the area was reclaimed. Okay, so during your monsoon period, so siltation was occurred. Siltation was occurred. You can see the siltation was occurred as per plan basically. So we planned that this area shall be reclaimed. Okay, so this area you see that siltation, except there are some few pockets where you have some depth basically, and that this is the drainage channel. This is the drainage channel. You just see. So now when we planned it, drainage channel was not very width was only hardly 7 or 8 meter of width basically. Okay, so idea was that if we redirect the flow will basically increase the width of the channel. Okay, so you need not. So final design width of the channel was during your lean period, it was around 200 meter. Okay, so now initially it was 10 meter, but during monsoon time, the width of the channel increases, and we got this channel. So now basically, yeah. So this is as river research point. The result was dramatic. The flow flow followed the design central channel. Sangam nose area was reclaimed, and the river bed stabilized naturally. And pre-monsoon intervention was proven to be very effective. So, so this is then basically. So we also after that means suppose post monsoon again we have taken the bathymetry, and then basically again we did some study, and based on that, what is the post monsoon activity? So that was suggested. So we suggested that this is the channel to be maintained, and here you can see this is basically showing that what is the depth of filling you need. So now basically what happened, almost it was silted up, but there are some pockets where some depth were there, and this is basically we have planned that this is basically the depth of filling required. So only thing you just see, there is no filling is required, only in this portion filling is around 0.5 meter or something, and but there are some portion where you need in some small pocket where you need the filling of around 2 to 3 meter of filling is required, but that is in small area. So we have calculated the volume basically. Okay, so now because after November we have hardly 1 month, or November means up to January first week we can work. So we have only 1.5 months or something like that. And within that period, so what you have to do basically, you have to artificially you have to fill this thing, and then we calculated that it requires around 23 days. Okay, so to mean suppose filled it up, and they did it finally. Okay, so this is the basically you just see. So this is the channel, dress channel. So this is the dress channel we got, and this is the reclaim area. So this is the reclaim area. Only thing is that some portion were not silted up, and that we have artificially we put silt on that by pumping, through pumping actually. So we put silt, and it was done by the irrigation department and continuously for almost 1 month, and then finally it was completely reclaimed. So this is some of the means photograph during this thing. And now for the reclaim area, because there will be a huge crowd, so therefore we have also used to stabilize the soil, we use geomattress basically. So during, and this is some of the photographs taken during construction of this work. And finally you just see, once everything is done, so this is the basically the reclaim area. You can see this area is also reclaimed. This area is also reclaimed. Original your river bank was somewhere here, river bank, and this entire area was reclaimed. This is basically just before, I think this photographs was taken around first week of January. So Sangamnos area once eroded and fragmented has now, and you just see there is one channel now. There is one channel. So you just see, so earlier there are multiple channel in this area, but now there is only one channel. So this is and the reclaim area is now stable, accessible, safe for hosting millions of pilgrims. So they also got lot of area. Okay, so they also got lot of areas for the Kumbh Mela. So you can see this is the reclaim area. This is the reclaim area. You can see. So this is the area which was reclaimed. So this is basically once complete siltation was done. So this is the reclaim area. So there was some media report. So I just want to be. I don't. Audio is not there. Audio is not there. Anyway, so there was some Akashvani report also on this particular study, but it was reported in many your newspaper and TV channel. So, so finally, so you just see the planning is the first part. Okay, so planning is the first part of your project. So I understand that it was not a means easy work, because we have only 1 year to complete that one. So then that was the challenges we had basically. But what I feel basically, rather than planning, implementation was much difficult. Okay, so so implementation was yeah. So implementation. Someone will come now. Okay. No, sound is not coming. Just 1 minute. Yeah.
महाकुंभ में श्रद्धालुओं को संगम पर सुगम स्नान की सुविधा देने के लिए गंगा की 3 धाराओं को एक कर दिया गया है। शास्त्रीय ब्रिज से संगम नोस तक 3 धाराओं में बह रही गंगा को एक किए जाने से श्रद्धालुओं को पहली बार एक ही स्थान पर स्नान की सुविधा मिलेगी। पेश है एक रिपोर्ट। प्रदेश सरकार ने आईआईटी गुवाहाटी के विशेषज्ञ टीम से सर्वेक्षण कराने के बाद 4 विशाल ड्रेजिंग मशीनों की मदद से गंगा के प्रवाह को विस्तार दिया है। इस जगह को समतल करने के लिए 5 लाख मीट्रिक टन बालू का इस्तेमाल किया गया है। वर्तमान में मां गंगा की एक धारा में प्रभावित होने से मेला क्षेत्र को करीब 22 हेक्टेयर अतिरिक्त जगह मिली है, जहाँ बड़ी संख्या में श्रद्धालु एक साथ एक जगह पर स्नान कर सकेंगे। आकाशवाणी समाचार कक्ष से शैलेंद्र शर्मा। महाकुंभ में
What I said basically, so planning was certainly challenging, and it was there are a lot of uncertainty when you are going for river training work. So as expected, you may not get the result, but in this case, we got whatever we have expected. But what I feel basically, because I was there during implementation of this project also, so it was basically more challenging suppose they have only very limited window, and I still remember he was a student of NIT Allahabad, so he is working in this particular project. So he was a student, he is now working in irrigation department UP. So he used to call me at midnight also, basically. So then he said that, sir, this is happening. So it was quite challenging. But finally they could, and they work almost day and night from your November to December, basically. So they work day and night. So that was your lot of challenges were there finally, but they could implement this one, and this is the hard work of the Uttar Pradesh Irrigation Department. So I would like to, this is the special thanks to the Uttar Pradesh Irrigation Department for their tireless coordination and flawless execution, turning a complex plan into a successful reality. Plan was very complex, and as I said, that I would have been very happy or get better result if we could use the porcupine screen. But because there was some issues, so we could not use porcupine screen. But with the Zio cutter also, we got a very good result. So in IIT Guwahati, so I was there, and Professor Suresh Kartha, and we also, our PhD student and MTech student, they have also helped us basically. So this is the IIT team. This is all about the project we have implemented or we executed for Kumbh Mela. Thank you very much. So if you have any question or anything you want to know, basically, yeah, you can ask. Thank you. Thank you so much for listening.
Professor Rajib, excellent work. I mean, totally field orientation and such an excellent results before Kumbh Mela. It was challenging, of course. I was trying to know because it very little bit time. So when you reclaim that is mainly sand bed kind of thing. Whatever you have reclaimed, that is mostly sand. So how did you check the stability or its strength? Because so many people will be walking around.
So what they did basically, so I didn't show it, but I have shown one figure. I've shown one figure. So suppose reclaim portion, that bank stabilization was done basically. So we put the Zubek revetment along with apron and all those things. So we put it, okay. And then so whatever the portion they have compacted by vibration, okay, so they have compacted, and then actually so they also put the geometry. So that was actually, if you look at just 1 minute, yeah. So if you look at here, yeah, so This is the bank revetment. So actually, we have designed the channel in such a way that the bottom width of the channel is around 200, around 200 meter, and that is the width required. So during this time, discharge was around 2000 cubic. Okay, so and it was controlled, as I said, the discharge was controlled by the Kanpur barrage. So now for 2000, so now we have designed this channel. So now when we design, so we have kept that 6:1 vertical slope basically, and there is a bank revetment with apron and all, and then the geosynthetic was used. Okay, there basically, and the other portion they have through vibrator basically, so they have stabilized the soil
So this they did periodically or towards the end?
towards the end.
Towards the end.
Because we only got so because after I said that only the water receded. So after that, actually they did it. Okay, and they also put seal because there are some area where still basically uneven area. So they pump the seal from the main channel. They pump it, and then during that time they have stabilized it. Yeah.
Thank you.
Thank you so much.
Hi, Professor.
Thanks.
So I lived in Allahabad for 1 year, and I was there for Kumbh Mela. So if you're walking in that Kumbh Mela area, people may not realize that they're walking on the river. So it felt like you're walking in a tent city. So I think that was a good feeling. And my question is, so now we have a lot of sediment in that region. So what will happen during this monsoon? So what will happen to the sediment?
Yeah. So actually, after Kumbh Mela, I didn't visit that one. So we had a meeting just last month. We had a meeting. Then meeting. Actually, there is already Geo cutter set there. So Geo cutter, because once Geo cutter is there, the flow will be diverted. Okay. So bank will be, and this apron is already there. But what they said that to during Kumbh Mela time, they have actually destroyed some of the Geo tube. Okay, Geo cutter they have destroyed. Then there was a planning that they want to put some of the Geo cutter again in order to stabilize this thing. So they had some basically proposed work, but I'm not sure whether they will implement it. But they, we said that this is required, and that Mela Adhikari. So now he has been transferred to Lucknow. So he was also interested because we have reclaimed this area and we should actually preserve that one. Okay, so that will also be used in next Kumbh Mela or anyway. So every year we have Maghi Mela. So during Maghi Mela also you can you need this space. I think that will be stable. So already Geo cutter tubes are there, but if there is some small maintenance is required, so that will be implemented by them. Yeah.
Thank you.
Thank you, Professor. Nice work. Actually, I am also from NIT Allahabad,
Yeah.
assistant professor. So there is a one issue that while using the porcupines, like we are using the porcupines to silt that place, and near the Nag Vasuki, there are porcupines. So siltation has occurred, but in the mainstream, it is very difficult to put the porcupines. So what are the major issues or concerns that was related to the porcupines deployment in this Sangam area from your point of view?
No, basically, as I said that I would have been happy to use porcupine. Okay. So only thing is that you have to design the porcupine. So how much porcupine you should give, what should be the spacing, in what layer he will give. So this has to be designed. But we didn't use it. One is that they are not comfortable with porcupine. This is one. And in Assam, actually, suppose you will get a lot of contractor. So a lot of good contractor, knowledgeable contractor, and if you say they will implement it. But here there was some issue. And second is that because if you are putting porcupine, that concrete will be there, concrete bar will be there. And during Kumbh Mela, because some of the bar will be above the above the ground level, and it will create. And again, you have to cut it, or there will be some. So that's why we didn't use porcupine. So then actually we suggested there was another, because another method we use in Brahmaputra for channelization, bamboo bundling. Okay. So bamboo bundling could have been, but again, there was some issue with the expert, so expert contractor and these things. So we didn't use bamboo bundling. So bamboo bundling could have been better basically for siltation. Okay. So you can reduce the flow, you can divert the flow towards the main channel, and you can also induce siltation. That is, so generally inland navigation, they are using bamboo bundling.
and that also you can design. But somehow, so it was easy to use for this geotube cutter, because you put it and then pump the sand inside. It is easily can be implemented, and there are some very good knowledgeable people. So we use that one. So we never use. But there are some area where they have used porcupine. Okay, it is working or not working? Working. Yeah, it is working. I know porcupine would have been better, and but we didn't use because of that reason. Yeah.
Thanks.
Thank you. Okay. Thank you. Thank you so much. Okay. Thank you.
Thank you so much, sir. Now I would like to request Professor Vishnu Prasad, sir, to facilitate Professor Rajib Kumar Bhattacharjya with a memento. Now moving on to our second technical keynote speaker, it is my pleasure to introduce Professor V Umamahesh, whose remarkable contributions have significantly advanced water resource engineering and flood management over the past 3 decades. He earned his BE in Civil Engineering from Osmania University, followed by an MTech in Water Resource Engineering from IIT Kharagpur, and PhD in Civil Engineering from NIT Warangal. He currently holds the position of Professor HAG in the Civil Engineering Department at NIT Warangal. He has previously held many leadership roles, including Dean Academic, Dean Planning and Development, Dean Students Welfare, Head of the Civil Engineering Department, and more, clearly demonstrating strong administrative capability. He has published 67 peer-reviewed journal papers and authored 9 book chapters. And he has earned prestigious awards such as Jal Mitra Award, GM Navate Award, a Best Paper Award at the International Modeling Tools Conference, and the Best Engineering Faculty Award from NIT Warangal. So let us all extend a warm welcome to Professor V Umamahesh, and I kindly request sir to deliver your keynote address.
So good morning to all the dignitaries and participants present here. It's a pleasure to be here and give a talk on urban floods. It's a major issue that's facing most of the cities in India are facing today. So what I'll just talk about is based on experience that when we worked on urban floods during a project that we have got from ITRA, where we worked with along with IISc Bangalore and then BITS Hyderabad and NIT Warangal together worked on a project on urban floods. So what are the issues and challenges that we face today when we talk about floods in urban areas? Okay, no problem. Okay, so if you look at the data about the natural disasters that are from 1970 to 2019, you can find the most major kind of natural disasters are floods, and then droughts, and extreme weather. Yeah. So mostly we find that the floods are the major natural disasters that occur across the world. So when compared to other kinds of floods, but most of the floods, most of the natural disasters are caused because of the extreme weather, whether it could be floods because of extreme flows, extreme rainfall, or maybe droughts or extreme weather or extreme temperature, etc. So if, in fact, if you look at the natural hazards, I think there is a significant rise of number of natural hazards occurring across the world from 1980 onwards, a steep rise. And the same thing we can observe in terms of, in case of floods. So obviously floods are one of the major natural disasters that occur or that affect across the world. Okay. But what we talk about today is what we call as urban floods. The urban floods are different from what you observe in riverine floods. In fact, in terms of the volume of flow that take place, I think urban floods are very, very small and compared to the floods that are rivers. And but still today, in fact, across the world, most of the city planners are placing a major challenge in planning the cities to overcome this floods, because the major problem with urban floods is they occur in a very short notice. They occur very short notice. You can have just a 15 minutes rainfall and causes a flood in certain areas. I think many of you who come from cities have faced this problem in one of your cities. And then uh, the losses that are caused because of these urban floods are most significant. The reason is, again, the population as well as property is concentrated in small areas, and that's one of the reasons. So if you try to look at the reasons for this, sorry. In fact, I think these are the pictures that you can see in most of the cities these days. I just borrowed some pictures, like, for example, I think Hyderabad faced a severe floods in August 2010, and then Bangalore floods to 2010, and then I think all of you heard about the Chennai floods that occurred in 2015. Uh, as far as Chennai and Mumbai are concerned, the floods, we have an explanation because they're coastal cities, they are affected by cyclonic storms and all those things, so floods are common there. But cities like Hyderabad, Bangalore, or even Delhi, I think these are cities which we never heard about floods maybe a few decades back. Because I belong to city of Hyderabad, I brought up in Hyderabad. I know in 70s and 80s, when people talked about, say, when we talk about heavy rainfall also, we never had that kind of situation. We never, in fact, floods were unknown to us. But today, Hyderabad is one city, I think, along with other cities like Delhi or Bangalore, that faces a very severe problem every monsoon. And so this is what we are a challenge that we are facing in most of the Indian cities today. So what is the cause? Okay, we can naturally attribute the cause. One of the cause that people talk about is climate change. The climate change is causing intensification of rainfall, and because of which there are more heavy rainfall incidents occurring. That could be one of the reasons that we have for this thing, frequency intensity. But most of the time, it has a human causes. The way that urbanization taking place in most of the cities, the rate of urbanization that's taking place, and then most of the time we are encroach upon the water bodies, and lot of, though in fact, and even if you have a drainage system, most of the time they are not maintained properly because they're open drains. During non-monsoon season, they get silted up and then clogged. And then, okay, most of the times the cities are, urbanization has taken place by a lot of deforestation. So all these are mostly man-made causes. So we have natural causes because of heavy rainfall, which is caused because of climate change. But again, the heavy rainfall is also attributed towards urbanization. So let us look at what's the impact of the urbanization on the rainfall pattern and the hydrology of an urban area. Okay, so if you look at a natural terrain, by natural water balance, we have precipitation and then a lot of evapotranspiration because there is a lot of vegetation there, and a lot of evapotranspiration, and then we have infiltration. A large amount of water also infiltrates because soil is permeable, and the amount of runoff produced is very less. But what happens because of large cities? What's happening is the amount of rainfall that occurs is not sufficient to meet the demands here because of high concentration of population. We start importing water from, say, different areas. A large amount of water is being imported, and then most of this water that we are supplying for either domestic or industrial consumption comes out as wastewater. So there's nothing like wastewater discharge here, but we have a huge amount of wastewater coming out of this. And then the infiltration got reduced, and then evapotranspiration got reduced because we have, made the land impermeable as well as vegetation gets reduced. So what happens is we start generating more amount of water as runoff, which is obviously also poor quality because of a lot of debris and waste that comes out along with it. Okay. And when you look at the hydrology of the catchment, say in urbanization, obviously affects the flow pattern. One is there'll be a shorter time for peak because the velocities have increased because of paved areas. And then we have a larger peaks because we have less infiltration and lower base flow, and then higher peak flow because of this, and maybe more frequent stormwater runoff events because rainfall, extreme rainfall events occur more frequently. And the total annual runoff also increases because we reduce the infiltration, and thus the base flow contribution is reduced. And these are the different changes that occur mostly because of urbanization. And the other major factor, I think many of you have heard about it, what we call as heat island effect, where because of one area, the heat gets concentrated here, and then because of which we find that there will be changes in the circulation pattern and can change the rainfall pattern. And so we may have more rainfall, heavy rainfall events occurring on the downstream area of the direction of wind flow. So we try to investigate did some studies in Hyderabad. The study was done almost 10 years back. We tried to study the rate of urbanization in Hyderabad. So this is how Hyderabad looked in 1972. The red area is the built-up area. The amount of built-up area is very, very, very small. And as we move towards 2013, because the last figure that we got is 2013, maybe today 2025, I think maybe this area would have become larger still because a lot of urbanization has taken place in the last 12 years also. So we find that the city has expanded rapidly. In fact, if you look at the built-up area, total built-up area, it's expanded very rapidly and exponential growth. There's an exponential growth, especially after, I think, 1990s, 94. Maybe, as you all know, Hyderabad has become one of the centers of IT centers after Bangalore. So a lot of IT industries and then industrialization has taken place. And because of this, you find that the city has grown in this direction, and then it has become a huge city today. So what's the impact of this? We made a study on the different rainfall, extreme rainfall events based on radar rainfall data that we got from the IMD. And the four indices that I'm showing here are, one is what we call SD11, which is the ratio of annual precipitation to number of wet days. So you say there is an increasing trend here. And then R20 is the number of days in the year when the rainfall is more than 20 millimeters. There is an increasing trend in this also. And then we took annual rainfall from days where the rainfall was more than 99th percentile. Even that also there is an increasing trend. And the maximum number of consecutive wet days, there is a decreasing trend. What all this indicate is that there is a change in the extreme rainfall. We found that the total annual rainfall has not changed in the city of Hyderabad. But the extreme rainfall, that means the number of rainy days have decreased, and then there's going to the same rainfall is occurring in less number of days, and so there's a more extreme rainfall events occurring. And when we look at the monsoon rainfall over the 4 months of monsoon from 2001 to 2019, you find that the number of instances of heavy rainfalls have increased in the last few decades, the last 1 decade. So we find more number of instances of occurring, especially in August and September, we find a lot of such rainfalls. And what is the impact of all these things? Okay, we talked about this urbanization, but at the same time, there's also change in the climate because of urbanization as well as a global climate change. So we all know that this climate change is going to influence the frequency of occurrence of the extremes. So why does the frequency occur? We study the, say, we do a statistical analysis of the extreme rainfall, extreme events using probability distribution functions. So what you normally observe in many of these things is, for example, when you look at, like, for example, I just plotted the, in fact, it's mentioned in terms of temperature. So, for example, there's a probability distribution of the temperature before the climate change, but the climate change could cause a change in the mean. So change in means what happens, the extreme hot weather, the instance of extreme hot weather can increase. And similarly, there could be change in the variability. So that can increase both the extremes. And also, we find that there could be a change in the symmetry of this distribution. So the change in the distribution pattern can cause the frequency of these extreme events. And this is what we wanted to study. And I think most of you are aware, we use what we call as intensity duration frequency curves in order to do the drainage design in urban areas. What are these intensity duration frequency curves? We plot a graph between the intensity of rainfall against duration for different return periods. So this IDF curves are mostly used for determining the peak discharge from small catchments and drainage of drainage systems. So a typical IDF curves look like this. But as I already mentioned, the climate change, urbanization, this can impact the distribution of the extreme rainfall, and thus the IDF curves need not remain stable. So in fact, most of the statistical analysis that we perform to do this frequency analysis is based on the assumption that the probability density function that we estimate or we say fit based on the past data remains same in the future. But the future is not going to remain same. So I think many of you would have heard about the non-stationary frequency analysis that is more being commonly used these days, where we assume that frequency distribution is not stationary, it is non-stationary, and then we, as I already mentioned, the probability density function, the mean as well as the variance as well as the shape can change. So we expect them to change with time, and accordingly we did a non-frequency frequency analysis to see how the IDF curves are affected because of the all these factors, both urbanization as well as the say the climate change. So we plotted, say these are results that we got based on the non-stationary intensity frequency analysis that we have performed. So these are 2 years, 5 years, 10 years, and 5 years, 25 years return period rainfall. This thing. So you can see that in all the cases there is an increase in the say rainfall intensity for a same duration. So we'll look at the results. Stuck up. Okay. Now, if I consider an extreme event with a return period of 2 years and a duration of 1 hour, you find that the stationary analysis has indicated 42 point. Now, the conventional analysis that we do gives us the rainfall design rainfall of 42.85 millimeters per hour. Whereas when we do this non-station analysis, it's 53.86 millimeters per hour. If I take the same thing for 5 years return period, you find that the station analysis 52.26 and then 60.85 for non-station analysis. Let us say we design the drainage system for a 5 years return period event in a city like Hyderabad. So we would have taken this 52.26 millimeters per hour as a design intensity and then accordingly designed the drainage system. But what we observe is now under the changing situation, the same 52.26 millimeters per hour is occurring once in every 2 years. It means the frequency of failure of this has increased. So this is an impact that we have to consider. This is something which we need to consider. So one of the challenges that we face today is, how do you identify the risk of climate change in urban infrastructure? We have designed traditional design methods where we do the traditional frequency analysis and then accordingly fix the return period, and then based on return period we find the magnitude, and for that magnitude we're designing this. Whether it's an urban drainage system or maybe bridges or other infrastructure that we design. But now the climate change, or say, how does it influence the risk? And then how do we fix the design return period? Design return period has been fixed for different structures. I think we have a standards. So most of the urban drainage systems are designed for 2 years or 5 years return period. Now, if I have a culvert, maybe we design for 20 years or 50, 25 years, or we have different things. This is based on some economic analysis that is performed. But now, obviously, under the changing situation, we need to see how to incorporate this. Because return, what we call as return level or return period is not constant. No, it's changing continuously with time, because of the changes that take place in the hydrology or say extreme. So how do we incorporate them in this? It's easy to say on paper like this, but I think when we go onto the field and then try to implement this is a challenge that we have. How do we change our norms or policies to do this? And how to incorporate this changing return levels into design procedures? I think these are challenges that we need to look into when we go into the future. Okay, so we talked about how the climate change or the urbanization has caused an impact on the rainfall pattern. But as I said, it's not just only the increasing intensity of rainfall that is causing the flooding. We wanted to show what is happening in Hyderabad through, again, another example. We tried to, in October 2020, Hyderabad faced a very, very severe flooding event. Okay, so we tried to do an analysis of that. We did an assessment of this 2020 floods, October 2020 floods. Okay, this is Hyderabad. In fact, Hyderabad, there's a river called Musi that's flowing through the river, and then you can see a lot of lakes situated all in the city. In fact, I think I understand Bhopal is called as a city of lakes, but I think even Hyderabad was used to be called as a city of lakes because there are a lot of lakes in Hyderabad also. But unfortunately, we don't find many of these lakes today. That's one of the reasons for more flooding incidents happening in Hyderabad. So, and this is a major lake. I think say the entire city is divided into a number of zones in terms of the hydrological characterization. So we considered this is one zone which faces, this is the old city area, which faces a lot of flooding incidents. And these two zones, so what we call as zone 12 and zone 13, these are two zones which are highly urbanized. And then they also face a lot of problems during the monsoon season. Most of this, all these areas drain into this lake, what is known as Hussain Sagar Lake. And then from the Hussain Sagar Lake, the outflow goes into Musi River again. Musi River is a tributary of River Krishna, but actually what you call as a river here is just like a nala today, mostly polluted. I think the government of Telangana is now taking up to go for rejuvenation of this river. So we have just confined our study only to 3 zones because these are 3 priority zones, zone 12, zone 13, and zone 5. But mostly I'll show the results of zone 12 for this analysis. Now, if we just try to look at in the last few decades, what are the major rainfall flood events that occurred in Hyderabad? So we identified the severe most flood that occurred in the recent past is what has happened in August 2000, which there was a rainfall of 241.5 millimeters in a single day, which is a major rainfall event and has caused in fact, loss of lives of 26 people, and then more than 35,000 houses were affected, more than 2 lakh people were affected, and a loss of 135 crores. And the next major event that you find here is what we call the event that we studied now, where October 2020, where only the rainfall was 192 millimeters, daily rainfall, 24 hours duration. It is less than one when compared to what has happened in 2000. But the number of lives lost was this thing. But the loss actually is more than 5,000 crores. And number of people affected was almost 1.8 lakhs. This is statistics that we got from the city of Hyderabad. And then we did a study where we try to study the land use, land cover changes that happened between 2020, 2000 to 2020. So we considered, say, multi-temporal space satellite data, Landsat data from 2000 and central data, and then we did analysis of this LULC classification, and based on that, we tried to check based on Google Earth this thing, and we used an HECRAS model, hydraulic model, in order to simulate the rainfall event, and then find out what's the extent of flooding, say flooding happened in the city. Now, this is a comparison of rainfall of 13th October 2020 and 23rd August 2000. You find that, in fact, the rainfall that occurred in 2000 was spread continuously over the entire 24 hours period, and then we have multiple peaks. But most of the rainfall in 2020 was concentrated only during few hours of the day, though it's actually 24-hour rainfall, but most of the rainfall occurred just within a few hours in the day. So that's maybe one of the reasons why there could be more flooding there. But when we look at the analysis of land use, changes in land use, we find that between these 20 years, I'm just looking at only the 12th zone where more urbanization has taken place. The built-up areas changed, occurred, say, in fact, you find that 23.75 square kilometers in the additional built-up area that's built up here. The amount of vegetation land has got reduced, and then say other areas also, obviously there's a decrease in the other areas. The amount of water body, there's a slight decrease, in fact, with the water body, the amount of area of water body. But otherwise, most of these areas have, in fact, decreased, but at the cost of the built-up area. Built-up area has increased because at the cost of other land use patterns. So this is a comparison that we made. This brown color here, what you find here, the purple color, these are the areas which have got inundated during 2000 flood. Whereas this dark blue areas are the areas which got inundated or flooded because of 2020 event. So find that there's a significant increase in the amount of area that got flooded in 2020. And if you look at comparison in terms of the amount of the risk, deluge risk in terms of the classified three categories, low, medium, and high, you find that there is an increase in the area that's got flooded in all the, say, three categories when compared to what it was in 2000, 21.95 to 34.05 square kilometers. In fact, actually, we try to, I'm not showing the results here, but we also try to simulate the same rainfall of 2020 with the land use pattern of 2000, and then found that the area, the amount of area that could have actually got diluted because of flooded during that would have been less smaller than this 21.95 if the same say land use pattern would have been there in 2020. Now, one of the reasons we did a study based on the change in land use and other things, we find that, okay, for example, if you look at these two pictures here, this is 2000, this is 2020, you find there are the small lakes here. Most of these lakes have almost disappeared or almost the verge of disappearing because there's a lot of encroachment and a lot of urbanization in these areas. Okay, encroaching into the say water body areas. And the same thing, this is these are the tanks that I'm showing here. For example, here, this area, so this lake has practically disappeared here. If you look at this point, this left side part is 2000 and this is 2020. Okay. So this is what happened, how the, say, in fact, the area got disappeared. So what I will say is that there is one of the reasons why this more flooding is occurring in Hyderabad is because of encroachment land in many areas. Okay. In fact, there's a kind of situation that you find in most of the areas. The drains are not properly maintained. There's other issues that we have in many of the cities. I think this kind of photographs you find in many of the cities that we've across the country. Now, one of the challenges that we face when we try to model the flood is most of the time we don't have short duration rainfall. In fact, Hyderabad also we could get only hourly rainfall, but we need a shorter duration rainfall. We try to use techniques like disaggregation, etc., but still it doesn't work. And then we need a high resolution dam. We work with only 10 meters resolution dam, but a city like Hyderabad, we require a much higher resolution dam. That's one of something which is lacking. And then calibration of hydrology models is one of the problems that we face here because most of the time we don't have any flow data. In fact, we try to calibrate using the what we call as social network markers, where we have water logging data from different social networks, and then we try to compare with the simulation network. That's a very, very approximate way of calibrating model, HECRAS model, but not the correct way. But unless we have data, we cannot do it. So how do we tackle these issues? I think I tried to mention some of the things. I think what we require for cities like Hyderabad or Bangalore and other places is development calibration of HMHS, HECRAS-based flood forecast system. I think for all the zones, this is going to be different from the normal flood forecast system because we require a final resolution, temporal resolution for forecasting. Say, because in river systems, we make a forecast 1 day ahead or 2 days or 3 ahead, but I think here we need at a hourly interval or something like that. We need a real-time forecast system because that's how we can reduce it and then develop vulnerable maps. And actually, I think our cities, most of cities, in fact, this is how the transition of cities occurs. Most of our cities are actually somewhere in this region, but I think we need to make our cities more water sensitive. What I mean by more water sensitive is I think we start looking at all sources of water and then start using recycling the wastewater, try to import less water from outside. So most of the wastewater gets recycled, even stormwater can recycle. I think these are the ways in which we can try to improve the urban city. So I think what we require is we need to look at stormwater as a resource, not as a nuisance. Most of the time, what we do is when we do the designs, we try to push away the stormwater from our premises and see that it's a nuisance. But I think we start looking at as a resource, and we need to control at the source. So I think we can try to attenuate and through retention and infiltration storage. We need to go for decentralized treatment of stormwater, and we can enhance the landscape and recreation places to improve stormwater infrastructure. And then I think we can harvest stormwater to supplement the water supply so that we can import less water from outside. I think unless we start looking at say water, all the source of water, I think as a single, as sources of water, not nuisance, I think we need to integrate with other systems, like I said, linkage with other systems like water supply, wastewater treatment, disposal. I think they're all linked together. So unless we have an integrated approach, they are not separate entities. Unless we have an integrated approach, I think not be able to tackle this problem. So we have to improve the flood resilience of urban cities. So we have to start formulating guidelines. Okay, what damage has been done in a city like Hyderabad? I think we cannot undo it mostly. We may try to put some situations where you can try to improve it. But I think at least when we are expanding cities or 2-tier cities and 3 cities which are growing, I think we need to formulate guidelines because as on today, we don't have proper guidelines for urban drainage systems. In spite of which folks speak from it. So we need to formulate guidelines. So where we can try to integrate all the 3 sources of water and see that the new location, new urban air localities that are coming up, at least will not face this problem. We have to learn from the future what happened in cities like Hyderabad, Bangalore, etc., and see that the other cities are not going to face a similar kind of situation. So let me end with a talk with a quotation that I have borrowed from a book on Commission of Inquiry into Flood Resilience, which is submitted to House of Commons in London. What is required as a fundamental change in how we view flood management, flood defense, where we protect ourselves to one of resilience, living with and making space for water, and the opportunity to get more from less by seeing all forms of water as providing multiple benefits. Thank you.
Any questions? Thank you very much, sir, for your valuable session. Now I would like to request Professor Ruchi Khare to felicitate our keynote speaker with a memento. Thank you, everyone. High tea is arranged outside the auditorium. Please have it. And after high tea, our technical session will start. In the all parallel sessions, TS1, TS2, TS3 and TS4. TS1 is civil auditorium, TS2 is mechanical, that is backside, and TS3 is electrical, that is in front of mechanical, and TS4 is energy center, that is in front of that civil auditorium. If someone is left with their registration, registration desk is open now. You can do registration in 102. For professors, high tea is arranged in right hand side.